everyone for inviting me to speak at this conference. I'm coming to you from Shenzhen, China right now. So if there's some late, it's not that it's late at night here, it's that we are going through the Great Chinese Firewall for this Zoom call. So apologies if I stutter. I'll do my best. Maybe just a couple of words about myself. I am a bit of a hybrid person. Born in Canada, spent over half my life now in Europe. I have studied architecture, but I've always had a affinity to computation and computing. And that's been the leitmotif of what I've been working on for the last 20 to 25 years. This is a professorship at the RWTH Aachen. About 7 or 8 years ago, I was called to the TU Delft to set up a similar there, be the dean of the university. And since 2020, COVID notwithstanding, I've been the dean and professor here at the Tsinghua University in Shenzhen, which is the very first satellite campus that Tsinghua University has set up. And just a side note, everyone wants to know, what was your first computer? Well, mine was a PDP-11. I started working on that in 1974, and we can compare notes later. Maybe a couple of words about the institute that we're trying to build here. I'm one of 3 right now at the institute. We are having 3 or 4 more come on board. Basically, we are trying to reinvent some of the pedagogy about architecture and engineering. And taking a 21st century approach to that. Partially that means thinking it borderless, so we don't have faculties at this university. We have institutes, and faculty members are not a member of any one faculty. They are just professors at large, try to find ways to address some of the issues that are sort of on our plates, and whether it's CO2 reduction or finding ways to be more resource efficient or make our cities more livable. All of these issues, we believe that they are going to be solved by interdisciplinary teams working on these research projects in cohesive, coherent ways. And we are also trying to teach the next generation how to do that. With that in mind, I'd like to use the opportunity today to talk about what I call the Internet of Doors. And if you've got the word bingo card out, I'm going to be addressing some of the things like topologies. I'm going to address blockchains, not because has running the construction blockchain consortium, but because I believe it's one of the keys to being able to have interdisciplinary teams that are and go into some of the things that machine learning can do, and try and wrap up with some of the challenges of the communication between these systems. And I'll connect the dots, or in this case, connect the doors. So without further ado, just so you know where we're going, I'm going to discuss the Internet of Things, and that's the intelligence that's percolating through all of our lives, whether it's our toaster or our smartphone or our. It seems that we are encouraging some kind of intelligence in almost everything we touch. I personally believe that art and habitation is the perfect place to start and end that. And I say by ending, I mean the place where an individual has the chance to say stop, in terms of their own privacy and in terms of their control of their own data. Housing units have a long time been the basis for most of our, I'll say, our legal status within the communities we're in. It's whether our ownership of property or our rental contracts, and even for the, let's say, in the construction industry, disaster or the building registry is also where ownership is determined and where assets are. Things are sold. So there's all sorts of arguments why we should think of habitation as a starting end point for this. And I'm just going to the thesis of this keynote is that it starts right with the door, and the front door is the place. So in a second. What I want to do is then walk you into let's say the logic stream that's brought me to this point. Topology is the key, and topologies are maybe misunderstood in some ways when people start talking about graphs and whatnot. But I have a sketch of what a strange attractor is. And what I like about strange attractors is that you never know exactly where the object is going to be, but in path, you know generally where it's going to be. You can describe where it is not going to be, and you can also describe the area where it can be. And often for the things we need in construction in our daily lives, that's enough. We don't need to know precision of X, Y, Z. We only need to know relatively where things are. And so if I have a bunch of data points, these might be sensors, these might be people, these might be smartphones, these objects that need to be tracked or traced. If I start to use an XYZ way to describe this, this means that I have two objects. I'm going to have to describe and calculate a relationship between them. And that means XYZ for one and XYZ for number two, and one link. And if you think of it bilaterally, it's actually two. If I start to add another into this equation and start to calculate the relational position of these objects, I start to have three links, or six if you want to be very precise. And as we go on to adding more, we end up with 6 or 12 links. And in this case, we have a diagram here, and there's 91 links. And for those mathematicians in the room, the number of links is n times n minus 1 divided by 2. Or if you want to talk about the bilateral ones, then you don't divide by 2. So it's basically, n times n minus 1 ways of connecting these dots. And this just means that as we have more and more points on the data, an exponential increase in a number of calculations we need to make, even just to see if another data point is related logically or positionally to another one. So if I want to know if I have two sensors, that one's temperature and one's humidity, or location or presence, I'm going to need to do all those kind of calculations. And that's an enormous overhead for any kind of position-related system that needs to know where things are and where they are in relation to each other. Now, I have a different way of drawing this or of describing this. And the very simple thing, architects in a room, they'll just go, well, of course. But if I just do this, then all of a sudden the relationship between these dots is clear. Things are rooms, they're together in rooms, or they're not in rooms together, or they're in the next room. And so two of the dots that might have been close to each other, but they have a wall divided, will of course not be as relevant to two dots that are in the same room and have the same, let's say, atmosphere or the same conditions or the same, say, topological relationship. And interestingly, if I start to describe things topologically, then it's a linear process of escalation. Every time I have another dot, I have one more thing to position in the topology, as opposed to an exponential relationship. And that also means I don't have to calculate things. If I declare them where they are within the topologies, then it just becomes a hierarchy of objects within each other. And luckily, in the IFCs, there is a class of objects called IFs. I've got it here on my slide, IFC spaces. And IFC spaces basically allow us to declare ahead of time where objects are within a described, let's say, geometry. And that means we'll have to do the computation once as opposed to every time. And it means that additional curve are linear as opposed to geometrical. It also means that usually that's enough. If I'm, for example, tracking furniture in facility management software, I don't need to know exactly where a chair is, but I need to know how many chairs are in a certain room. And then here we get to the point of this lecture. If I have a sensor in the doorway and I move the chair from one room to the other, well, the system just goes boop. I know that the chair has moved from one room to another. And that's enough precision to do most of the kinds of things we need to do to manage our people and the objects that we need to interact with as citizens. The Internet of Things. This is one of my favorite. This is a hotel in Beijing that on the wall of one of the conference rooms, they have about 8 HVAC systems. And each HVAC system comes with its own little controller. And so instead of having a central them all. They have a controller for each individual one because that's how the procurement worked. So if you want to change the temperature in the room, you have to go and turn the key on the right-hand side to activate them, and then go to each one and change the temperature. And this is the classic case of where the Internet of Things breaks down, because if there's not a way to decentralize the control, then it ends up becoming more of a burden than it's worth. One of the things that people are promising with this is that all of our refrigerators, shoes, buses, printers, etc., will all be intelligent to be able to speak together. Of course, that's not necessarily a good thing, but it is probably the case that that if I am the owner of the person, that I might want my fridge to tell my shoes that I need more milk, so that when I go shopping, it'll beep my phone and on that don't forget to pick up the milk. But that has to be something that's controlled by the citizens, and not necessarily that the fridge is trying to anticipate what I might not want in my fridge. That depends on having these nested hierarchies. And one of the interesting things is that if you start to look at municipal organizations, and I'm talking about the people who manage services for cities, and whether it's water or power or traffic or school systems or garbage collection, those aren't always in the same nested system of the other hierarchies. So the water system is actually on its own geometric topology, and the traffic systems are organized by a different geometric topology, and schools again are done in a different way, and they all overlap each other. They don't necessarily go by city, county, province. Those to overlap each other. So we end up having systems that want to connect with each other, but they aren't perfectly nested. They overlap, and we need to have a systematic way to be able to control and to manage the communication between these hierarchies, because as we move toward city in our societies, we are going to need to make sure that the water system can communicate with the traffic system, or can communicate with the school system. They are all going to be interrelated, especially as we move towards more precarious situations like ecological, let's say, not disasters, but acute moments of systematic breakdown. I'll use the word. One of the things that when we start to talk about this kind of information is that we need to be able to up the systems so that the ownership of the data remains clear. And I think the way to do this is to start, the private is the place to start. The privacy trumps everything else. However, once we start moving into, let's say, control systems for buildings, the wish of the users needs to be interpreted and connected to the learning process that an will use when a building is trying to anticipate and let's say predictively reduce the amount of energy that's needed. So there's a layer that needs to be inserted so that when a person gives a personal preference, that the building interprets that as a general request, not one connected to my identity. And this means that the building should know where, maybe who should do things, should always know who, and then that they know where they are. And this kind of segmentation right now is not in the kinds of systems that we see for building operating systems. I'm going to call them that for lack of a better word, but it's something that we need to start, especially as we move towards, I'm going to call it the blockchain security, or the privacy security that something like a blockchain can offer us. It means that as we start to use artificial intelligence to monitor these systems, they're going to interact with people who are personally, whether if I have a contract to have a rental unit and I start to interact with the system, well, I need to be able to pull my private data in the system so that when I leave my apartment and I end my contract, that none of my personal data remains connected to the building. The building can an occupant requests these kinds of things, because that will enable the building to learn and to better anticipate what the next person might or might not want. It needs to be done in a way that's very clean and very systematic. And that way that let's say the legal ownership of the information remains with the building owner as depersonalized, and always with the person as their records, which is difficult because there are all sorts of sensors that are going to be recording all sorts of information about the air quality, about the different types of information. And some of these are at a frequency that is maybe every minute, some of them are at frequency of every hour, some are there once a day, and then there are asymptotic things when we have a binary situation like a fire or whatever. And in those situations, we do need to know the personal data. We do need to know that there are 5 people in this part of the building if there's a fire. So we do need to go and find those people, but we need afterwards to make sure that the system will understand that there has been a fire, but that Peter Russel was in that building at that time, that we set up the system so that we can bifurcate the chain at the moment when an individual user wants to do that. We come to the point of all the going to put them. Well, the place is to put them in the door. We talked about the topologies earlier, and how the topologies are the sensible way to control the amount of data that we have. And mostly the location is a topological one. Well, the simple place is to put the sensors in the door. And there's a few reasons to say why this is. First of all, it is the topological transition between two. Is that door frames are usually next to power, and you don't want to have to go hunting through a building every year to replace all the sensors. If you have a way to get power to them, even if it's a PoE, power over internet, then that's better than having to chase the dead batteries all over. The other thing is that door frames allow us, by their nature, to have above head views, so we can see someone is or where objects are in the room. And we also have at hand level, so that we can have a human controlled sensor, whether it's an identity to open a door, or whether it's just the damn light switch to turn on the lights, that we have both of those within one place. And lastly, it's an empty cavity that exists in every building. And the size of our computers nowadays fit in. Like the computers in this little iPod case would outdo NASA 40 years ago. And so there's already a place that's at the right place topologically for all of the things that we need. So the door frame is actually the perfect place to do this. A few words about the blockchain, just to kind of get towards where I want to put some challenges. Chain, and for some of the people in the room that have been working for the last 10 years on this, they already know what I'm about to say. But for those who haven't understood that, I just want to recapitulate some of the things that the blockchain can allow us to do. The most important is that it allows the partners. The construction industry in the past has always been one of trying to outdupe the other in order to gain an advantage, to sue or find a way to make more money than your colleague involved in a construction project. And the fact that the blockchain allows this decentralized of the data means that we together have a joint interest in the success of the project. And so it flips this adversarial idea into one of commisery at worst, but of collaboration at best, where people gather towards a positive outcome of the project, and not just a positive outcome for themselves. And that allows us to encourage a quality, a pursuance of quality, as opposed to a pursuance of finger pointing of who didn't think of something or who did something wrong. It also alleviates this problem of control that a lot of people have an adverse reaction to. And it also means that once we start to consider a way of considering design development, then the transactional thing goes into the use of the building as well, so that every the sensor is a transaction of the blockchain of the building. And of course, the place to connect this to is the cadastre, that the owner or the building unit owner or the person who's renting it owns that part of the chain that is attached to that transactional description of the development and use of the building. And it can all be run by the doors. That our blockchain actually becomes a door chain of these ledgers where we can distribute the computational power with the doors themselves. And if we need to, we can reconstruct the entire building out of that, but that usually that each door work for themselves, monitor the passage of what goes in and out of their transition, topological transition, and any sensor information on topology in order to be able to, let's say, properly position the information, depending on the unit person renting or owning it, and then the person who might own the building, who is the landlord of that place, and keep the information on the right parts of the chain so that we can then bifurcate it. And that means that when a person ends their contract, they can just say, okay, I'm now, and then they will take their own parts of that information with them. And there are ways to split ledgers in the blockchain that we now know from Ethereum or other let's say, currency blockchains that have done this in the past. So we already know how to do that technology. We just need to prepare that so that when we start to use these kinds of technologies to manage our buildings, that we're able to ensure that the privacy stays for each individual. Last part of this, and I'll wrap up, is just to say that we need to have the communication that goes vertical and a communication that goes horizontal. And that means that the units within a building that are looking after the intelligence and automation within the individual apartment units will also need to talk to the entire building, much like a condo structure works for the inhabitants. We need to have this kind of structure for the intelligences we're developing for the construction industry. And need to be able to talk with the city that are providing the services, and whether that's input of power or garbage collection or transportation or water, sewage, all of those things need to be able to talk through the nested hierarchies in a vertical way to share information and to share knowledge. And we also have the horizontal connection so that learned responses that one intelligence has achieved can be shared. So if one unit is learning something about its inhabitants and how to better anticipate that, they should be able to share that horizontally with their peers, much the same way that we as human beings learn from each other through our own experiences and sharing things like in this conference. That even at the level of these buildings. Just a couple of slides left, but just to say, why do we do this? Well, why should we pursue these blockchains and worry about where the computation is, worry about the sensors? Why should we worry about nested systems? Well, we are trying to better built environment. We are trying to make a place for happiness, that our cities are a place of joy, a place of that we want to create those kinds of systems. And those systems will only encourage that kind of restful acceptance and restful peace if certain conditions are met. And that means that the services that we promise are going to have to be delivered. And you can bet that any of the people or cities that might be taking part in this conference are going to go back and say, we should work on this kind of technology because then we can serve our citizens better, to promise that to the citizens. So we as the people who are going to implement and create these kinds of systems need to have our act together, be able to deliver on the things that we are saying is possible. And they need to be well curated. Data is not something that you just dump into and say, well, I've got the data there, it's all okay. It needs to be curated. It needs to be taken care of, like all these things. And if they're built reliably, that people can count on having those kinds of systems when they call in them, then you will end up having a happy system, and that will then bring in our happy citizens. And so all of this is driven logic of happiness logic, as I call it. And that means, coming back to what I was talking about, having speedy systems that figure out where something is, that is by using topologies instead of XYZ or latitude, longitude, height, means we will be able to deliver very fast. And speed is happiness. If you've ever seen someone frustrated by a half a second delay in getting a web page up, then you'll understand that. It also means that having something personalized for you, but protecting your privacy, will also bring to our citizens happiness. Being able to trust the system, their personal data is not going to be finding its way somewhere where it shouldn't, and a system that can anticipate and much in the same way things become intuitive to use, that will also be able to provide the kinds of reliable systems that will give us calm confidence for the people living in these cities. And we, as the people who are driving the technology, I think have to have that as our goal, that the people that use the systems are confident in that which we're delivering. And the message today is that I believe this starts with the topologies, and it's going to be anchored in the door. And so to wrap this up, what we have as a summary is that the imperatives are: declare your topological locations at the get-go and make sure that your systems can deal with the topologies. You'll thank me later. We need to make sure that we can create blockchain consensuses, and that's the plural of that word, because that means that at each level they are working at, they need to be able to function as a consensus. It also making sure that within those hierarchies that they can communicate not only vertically within a hierarchy system, but also with peer-to-peer communication. And to quote Obi-Wan Kenobi, use the doors, Luke. Thanks for your attention. If you want to discuss this further with me, I'm in China, so WeChat's the best way to get in touch with me, but I also have an email, and I'd be looking forward to your feedback and your input. Thanks.